Hello, my dear student. Today I'll discuss most important topic that is your gamma function. Gamma function. So already you know there are two types of function you have in this, especially in this subchapter. One is beta function, another one is gamma function. Okay. So in this video I'll give some important information about the gamma function. Okay. So please write down the improper the improper the improper integral 0 to infinity e to the power minus x to the power n minus 1 dx is a function of n and denoted by gamma n is known as gamma function. Okay, so ultimately you have gamma n is equals to 0 to infinity e to the power minus x to the power n minus 1 dx. Okay, so here your n should be always positive. Clear? So this is the definition of gamma function. The improper integral 0 to infinity e to the power minus x to the power n minus 1 dx is a function of n and denoted by gamma n is known as gamma function. That means this information. And gamma n is equals to 0 to infinity e to the power minus x to the power n minus 1 dx, where n always positive. Okay, so that is a definition. Clear? Now you write down some properties. Properties of gamma function. Okay, number 1, gamma 1 is equals to gamma. Number 2, gamma half is equals to root pi. Next, number 3, gamma n plus 1 is equals to n gamma n. Like example, I can write gamma, suppose 5 plus 1. So 5 should be outside and 5 should be inside. That is n plus 1 n gamma n. Okay, this process will continue until and unless your n become less than 1. For example, here this 5 can be written as 5 gamma 4 plus 1. So same way 5 into 4 gamma 4, you may write this process wise and it will continue. Okay, so from here it is clear, if any value can be expressed in plus 1 type, that is 1 plus another, if above 1, then you can apply this. Another form you have, that is gamma n plus 1 is equals to factorial n. So now I have a question in your mind, which one should I consider? Basically this result is coming from here. This result is coming from here. If you continue, so you will get factorial 5. Okay, if you continue. Okay, same thing is here. The example you may write, suppose for example uh, gamma 6 plus 1. So here n equals to 6, and then you may write factorial 6. Basically this factorial 6 is coming from this formula n gamma n. Okay, so please remember this formula can be used when n is a positive integer. When n is a positive integer, and otherwise you can use this formula. Clear? Okay. Now you write down another property, most important property, number 5, gamma m, gamma 1 minus m is equals to pi by sine m pi. So your m value should be lies between 0 and 1. Example, suppose you have suppose you have gamma 3 by 4, gamma 1 by 4, correct? So from here you may write, basically just you can check, basically you can express this one into this form. For example, 1 by gamma 1 by 4 and gamma 1 minus 1 by 4. That means this one, gamma 1 by 4 is here and this can be written as here. Okay. So basically if you take LCM, 4 minus 1, it is coming 3. Is it clear? First you have to rearrange it. That is gamma 1 by 4 and gamma 3 by 4. That's why then I'm writing this. Gamma 1 by 4 is here and then gamma 3 by 4 can be written as. Now anyone can tell me what is the value of m here? Yes, you are absolutely correct. M is equals to how much? If I compare, m is equals to 1 by 4. Now formula wise you may write pi by sine how much? Pi by 4. Correct. What is m? M is equals to 1 by 4. That is pi by 4. What is sine pi by 4 formula? That is sine 45 degree. 1 by root 2. Ultimately it is coming pi by. Clear? So these are the important property you have in gamma function. Okay. Is it clear? Now, next part is, now try to understand what type of question you can see from here. Please write down type 1 question. So please write down the question. Suppose evaluate 0 to infinity e to the power minus x, x to the power 5 into dx. Okay. Suppose you have a question. First you have to write on the right side, what is your formula? Standard formula, e to the power minus x, x to the power n minus 1 dx. Correct? First you have to write down. Now, so now anyone can tell me, if you compare e to the power infinity, range is same. So, sorry, range is same. E to the power minus is also same. Now here x to the power 5 and here n minus 1. So you may write n minus 1 is equals to 5. Is it clear to all of you? From where it is coming, just comparing. N minus 1 equals to 5. What is our target? To find n. So from here you may write n is equals to 5 plus 1 is equals to 6. So now you can rearrange it, 0 to infinity e to the power minus x, x to the power 6 minus 1 dx. Clear? So now formula wise, if 0 to infinity to the power minus x, x to the power n minus 1 dx can be written as, so automatically your n will be the gamma. So here gamma 6. Clear? Formula wise. Now, what would the gamma 6 value? Already you know the formula. What about the formula? Gamma n plus 1 is equals to factorial n. So you need to rewrite this as a n plus 1. So from here you may write 5 plus 1. So what is n here? If you compare, what is n? N is equals to 5. Your answer will be factorial 5. Clear? Okay. So this is type 1 problem. Okay. So just you have to revise it. So during exam time, similar type of question you can see. If you have a question from here, the number may be different. Okay. But try to understand the process. First you write down the problem. On the right side, you should have standard form of the gamma function. Then try to compare and find the value of n plus 1. Okay. Then find n, then substitute and simplify and find the result. Clear? Okay. Then you write down type 2. What about the type 2? So here 0 to infinity e to the power minus 3x, suppose x to the power cube dx. Okay, so first you write down your formula. Gamma n is equals to e to the power minus x, x to the power n minus 1 dx. Okay. Now, so first you have to compare. First you check range is same. Then your requirement is e to the power x minus x. But here it is e to the power minus 3x. Correct? So you need to replace it. So please write down put 3x equals to z. Okay. Then 3 dx is equals to dz. And from here you may write dx equals to dz by 3. Okay, so now here basically when you are putting 3x equals to z, basically you are replacing x variable in terms of z. Your range will be also changed. Okay, now x by z, when x equals to 0, so your z also 0. When x is goes to infinity, your z is also goes to infinity. Clear? So you need to write this. Okay, now so from here you need to write what is your x. X is equals to z by 3. Okay, so now you have three results. One is x equals to this, second one is this. So that means by these two results we can replace everything. Now, so from here your range will be same 0 to infinity, because when x is equals to 0, your z is also 0. When x goes to infinity, your z also goes to infinity. So this portion is clear. Now e to the power minus z, because already you have replaced. Now what is your x? There are three components you have, 1, 2 and 3. You need to replace one by one. So x cube means z by 3 to the power cube, z by 3 whole to the power cube. Now dx, what is dx? It is coming dz by 3. Is it clear to all of you? So first portion, second portion and third portion. Clear? Then this and then this. Okay. Now you need to extract number. So here you have 1 by x to the power 1 by 3 whole to the power 3, and here to 1 by 3. So from here 1 by, you may write 3 to the power 4. Okay. 0 to infinity e to the power minus z, z to the power cube into dz. Now you can see basically this form is similar to that. So 0 to infinity you have e to the power minus z, z to the power 3 you have. Okay, so what is n minus 1? N minus 1 is equals to 3. Okay, so from here you may write n is equals to 4. So here you may write 3 to the power 4, 0 to infinity, e to the power minus z, z to the power 4 minus 1 into dz. So from here you may write 3 to the power 4 and gamma 4. Is it clear? Gamma 4. Okay. So what is your gamma 4 value? Already you know. Gamma 4 can be written as 3 plus 1. That is gamma 4 can be written as gamma 3 plus 1 means factorial 3. So ultimately it is coming 1 by 3 to the power 4 factorial 3. That is the answer. Is it clear? So based on this, you should practice this question. Based on this, just you have to practice this question. 0 to infinity e to the power minus 4x, x to the power cube into dx. Clear? Just I have replaced 3x by 4x. Rest of the part same. You have to test it whether your knowledge is clear or not. Always, suppose you are doing mathematics in any topic, you need to check whether your concept is clear or not. Now I think it is clear to everyone. Now I'm switching to the next problem, next type. Okay. Now you write down type of 3. Clear? Now 0 to infinity e to the power minus 2x, okay, x to the power, suppose 5 by 2 into dx you have. 0 to infinity e to the power minus x, x to the power n minus 1 into dx. Clear? So now this is gamma n. So now you compare 0 to infinity. 0 to infinity is good, e to the power x, but here it is e to the power 2x. Okay, then what you do? Same process. You need to put 2x is equals to z. So 2 dx is equals to dz. So dx is equals to dz by 2. So first relation you have. Okay. Now you need to change the range. So x is here, z is here. Okay. So when x equals to 0, if you put here, that this z also coming 0. When x goes to infinity, that means z also goes to infinity. Clear? Okay. Now from here, so your what is your x? X is equals to z by 2. Now replace it one by one. So first you range you write, then e to the power minus z, then z to the power x equals to z by 2, z by 2 to the power 5 by 2. What is your dx? Dx is equals to z by 2. Okay. Now from here you may write, first you have to extract the number. So from here it is coming 1 by 2 into, this 2 is taken outside, and this also 2 to the power 5 by 2. Clear? Because 1 by 2 to the power 5 by 2, and 0 to infinity e to the power minus z, z to the power 5 by 2 into dz. Clear? I think it is clear to everyone. Okay. Now, so now this portion, just you can check, range is same. E to the power z is also coming same form, and that here n minus 1 is equals to how much? 5 by 2. So please write down, put n minus 1 is equals to 5 by 2. So what is your n? 5 by 2 plus 1, it is coming 7 by 2. Okay, it is coming 7 by 2. Clear? Now you need to substitute. Okay, you need to substitute. Now please check, is it okay? Okay, now, so now you have n is equals to 7 by 2. N is equals to how much? 7 by 2. So from here you may write 1 by 2 to the power 1 plus 5 by 2, 0 to infinity e to the power minus z, and z to the power 7 by 2 minus 1 dz. So already you know the formula. 0 to infinity e to the power minus x, x to the power n minus 1 into dx. Same from you have. So here you may write 1 by 2 to the power 7 by 2, and it is gamma 7 by 2. Okay. Clear formula wise? Now, so already you know from the basic that gamma 3 by 2 can be written as gamma 1 by 2 plus 1, that is 1 by 2 gamma 1 by 2 is equals to 1 by 2 root pi. Already you know that. Root gamma half means root pi. Same thing is here. If you want to write gamma 5 by 2. Okay, so gamma 5 by 2 can be written as 3 by 2 plus 1, that is 3 by 2 gamma 3 by 2. So gamma 3 by 2 already you know. So ultimately it is coming 3 by 2 into 1 by 2 into root pi. Correct? Clear? Same way we can rewrite gamma 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 7 by 2 is equals to, you may write gamma 5 by 2 plus 1 is equals to gamma, sorry, 5 by 2 gamma 5 by 2. Okay, so what is your gamma 5 by 2? It is coming 5 by 2 into 3 by 2 into 1 by 2 into root under pi. Clear? Clear? Okay, is it clear? So here we can write directly, that is 1 by 2 to the power 7 by 2, and gamma 7 by 2 means just always uh, 5 by 2 into 3 by 2 into 1 by 2 into root under. That is the answer from this. Clear? Okay, is it clear? Okay, so this is the process, and during exam time, so no need to prove it, no need to prove anything. Just suppose you have 7 by 2 that is less greater than 1, so you need to express n plus 1 type. Suppose 7 by 2, just 7 minus 2, 5 by 2, 5 minus 2, 3 by 2, 3 minus 2, 1 by 20. Okay, it is very easy, pretty easy. Okay, clear? Now I'm going to solve another type of question. Okay, type 4. Now please write down another question. 0 to infinity e to the power minus x square x to the power q into dx is a very important question. Okay, so on the right side, same process, gamma n 0 to infinity e to the power minus x to the power n minus 1 into dx. Clear? Clear? So now again you check 0 to infinity, same, e to the power minus x is your requirement, but you have e to the power minus x square, so put x square is equals to z. So from here you may write 2x into dx is equals to dz. So what is your dx? Dx equals to dz by 2x. So from here, what is your x? X is equals to z to the power 1 by 2. So from here you may write z to the power 2, z to the power 1 by 2. Clear? Same way you need to replace the variable also. Z, that is when x goes to 0, y is also 0. When x infinity, z also infinity. From here, so now you have three relation. So in place of dx we may write this one, correct, and in place of x we may write this, and from range part we may replace this one. Okay, now we need to replace one by one. First, same range 0 to infinity e to the power minus z. So already you have replaced x square. So there are three parts you have, 1, 2 and 3. Okay, so this part is over. Then x to the power q. What is x? Z to the power 1 by 2 to the power cube. Clear? Now dx. What is dx? Dx equals to dz by 2 z to the power 1 by 2. I think it is clear to everyone. Three parts you have, you need to replace 1, 2 and 3. Same thing, 1, 2 and 3. Clear? Now try to understand next part. So here number part is only 2. So you can take outside 2, then 0 to infinity e to the power minus z, z to the power. So here z to the power is 3 by 2. Another z you have, so you may write z to the power minus 1 by 2 dz. Okay, so from here you may write 1 by 2 0 to infinity e to the power minus z, z to the power 3 by 2, 3 by 2 minus 1 by 2 dz. So from here you may write 1 by 2 0 to infinity e to the power minus z. How much is coming? 3 by 2 minus 1 by 2. It is coming 2 by 2 means 1. So z to the power 1 dz. Clear? Is it clear? Okay. That's part by part you need to write. So clear? So in next step we may write 1 by 2 0 to infinity e to the power minus z, z to the power 1 dz. Correct? Clear? So this one 1 by 2 0 to infinity to the power minus z, z to the power 1 dz. Clear? So from here you may write what is your target? Our target gamma n is equals to 0 to infinity e to the power minus x, x to the power n minus 1 dx. Now you can see range is same. E to the power direct variable is required, here you have, but here it is 1. So therefore you may write n minus 1 is equals to 1. That means n is equals to 2. Replace it 1 by 2 0 to infinity e to the power minus z, z to the power 2 minus 1 dz. Clear? Is it clear? Okay. Now formula wise 1 by 2 gamma 2. What is your gamma 2? Already you know. Gamma n plus 1. What is your formula? Factorial n. Correct? Factorial n. Okay. So here it is an integer. Correct? Positive integer. So you may write 1 by 2 gamma 1 plus 1. What is n here? N is equals to, from this, n is equals to 1. So you may write 1 by 2 gamma 1. What is your gamma 1? Gamma 1 means what? How much? Gamma 1 is equals to 1. So ultimately you have 1 by 2 into 1. 1 by 2 is the answer. Okay, so these are the possible type of question from the gamma function. If these parts are clear, then you can solve all types of question from the gamma function. Is it okay? Okay. Thank you for watching this video and try to implement this knowledge to solve this question. 0 to infinity, 0 to infinity e to the power minus x square, x to the power 4 dx. Same process. So here I have considered only 4. Okay, question same. E to the power minus, already have solved e to the power minus x square and x to the power cube dx. So here I have given x to the power 4 only. Just follow line by line and try to solve it. Okay. Enjoy your study. Thank you. Thank you everyone.